we get to graph secant and cosecant, and these end up being really fun graphs. Okay, so for this one I have secant, and the secant function is the reciprocal of cosine. So what I'm going to do is just sketch as if this was cosine, and then I'll figure out what the reciprocal of that would be. Okay, when I look at this, I have this 2 here, and that affects the period. The period of cosine is 2 pi, so we go and take 2 pi and divide by that 2, so period is pi. And then this pi over 2, what that does is tells me the phase shift. And that is pi over 2. So my original cosine graph would just get shifted to the right pi over 2 units. All right, so I know that I have to deal with this whole secant thing, but here's my strategy. Okay, I'm just going to deal with it as if it was cosine, which I know it's not, but that's okay, we'll get there. X minus pi over 2. Okay, the phase shift tells me where to start my graph. So I start at pi over 2, and because it takes an entire period to get through the whole cycle, my end would be the phase shift plus the period. That tells me where I end. So I would end at, let's see, 2 pi, 3 pi over 2. And that's just kind of a nice little, that just helps me, my hack. You just, phase shift is where you start, and then you end, you just add period and phase shift. That tells you where to stop. Okay, now I'm going to do my cosine. All right, cosine, so we're starting at pi over 2. Cosine coasts down, so we're here. And we're done at 3 pi over 2. Good. Okay, so here's my graph of cosine. And it could keep going. Okay, now let me show you what happens with the secant. So what happens is secant is the reciprocal. Okay, so the reciprocal of 0, what's the reciprocal of 0? 1 over 0? That's undefined. So we'll end up with these undefined places anytime that the output for cosine is 0 because of that reciprocal relationship. Okay, so now we get our asymptotes, put those in, okay, and now it's always, we're thinking what would be the reciprocal? What's the reciprocal of 1? 1. And I'm not going to put all of these little numbers in here, but if we figured out what's the reciprocal, each of these places, let's see, this would be pi over 4, this would be 3 pi over 8. You'd have to plug that 3 pi over 8 in there, subtract pi over 2, multiply it by 2, take the cosine, figure out that number, and then do the reciprocal. So it's kind of complicated, the arithmetic of figuring these out, but graphically it's not actually all that hard to draw them. There's just these kind of cool little mirror images of each other. And so that's what the secant looks like. All right, let's try one more. Okay, now I'm going to show you the cosecant. All right, so cosecant, the relationship is that cosecant is the reciprocal of sine. Okay, so my strategy is just to deal with this as if it was a sine graph. Okay, use what I know. Let's see, we've got a phase shift. Phase shift is pi over 4, so that's where I'm going to start at pi over 4. All right, the other thing that's going on is I have this negative, and so what that means is that my graph is going to be reflected across the x-axis. All right, so my typical sine graph goes up, but now because of that reflection, it needs to go down. So instead, instead of coming up, I'm going to come down. Okay, but where is that next point going to be? Okay, so if I usually started at 0, 0, Now I'm slid over, and this point right here is at pi over 4. Okay, usually the period is 2 pi, and we don't have a coefficient in front of that x. That's just one x, so it doesn't affect the period. The period is still 2 pi. All right, so our original graph would have gone from 0, 0, and it would have ended at 2 pi. At pi, we would have been right in the middle. At pi over 2, we would have been down at -1. And at 3 pi, we would have been at +1. But now that whole thing is just shifted over to the right. And so we're going to be coming here. Instead of this point, we'll just be coming add pi over 4. Basically, everything's just shifted over. So we'll be here. And what you can do to figure out where those points are is we can take the original key point, 0, 0, and this is at 2 pi 0. This one is at pi 0. And this one would be pi over 2, -1, and this one would be at 3 pi over 2, +1. And then you just add pi over 4, you just add that phase shift to each of those x values of those key points. Okay, so here we would have, we were at pi over 2, but we've added a pi over 4, so now we're at 3 pi over 4 and -1. And this one would be at 5 pi over 4. Pi plus pi over 4, and then this point right here would be at 3 pi over 2 plus pi over 4. That is 7 pi over 4, and then this one is at 9 pi over 4. And that one is up at 1. Okay, so we're just shifting each of those key points for our graph. Okay, good. So we accomplished the first part, which is to graph y equals negative sine of x minus pi over 4. So we shifted everything to the right and we reflected it across the x-axis. Perfect. So now we need to graph the cosecant. Now what cosecant is the reciprocal of sine. So every time that sine is 0, my cosecant will be undefined. So I've got asymptotes coming through here every time we had the sine 0. Now my point is going to be the same, except I'm going to have the reciprocal. So I'm going to have this looking like a little parabola going through that same key point and up towards those vertical asymptotes. All right, and there we have it. There is our cosecant graph. Okay, now we're going to figure out just the transformations and not actually graph. So I'm going to rewrite my input a little bit and just kind of simplify that up as much as I can. So there's some stuff going on for x, so I'm going to just factor out, let's see, that's the same as basically x times a negative 1/6. So I'm going to factor out negative 1/6 in the input. Okay, just simplify that a little bit. Okay, so factoring out a 1/6, y equals 4 plus 3 cotangent of. All right, so we would get that basically is just like dividing by a negative 1/6 each of those pieces. So we would get x, and then dividing by a negative creates a positive. Dividing by 1/6 is the same thing as multiplying by 6. So we would have 6 pi there. Okay, now I need to really think about what's going on with this negative. I can't factor it out. Instead, what I need to do is simplify it using odd-even principles. Okay, so is cotangent odd or even? Well, let's see. Cotangent is the reciprocal of tangent. Sine over cosine is tangent, so it would be cosine over sine. And if I'm trying to figure out odd or even, I can just plug in the opposite of x and see what we get. Okay, cosine is even, so that would simplify to cosine x. Sine is odd, so that would simplify to sine x. Okay, and so then that becomes negative cosine x over sine x, which is the opposite of cotangent. Okay, so that means that we have an odd function. So I'm going to use the odd even principle. I'm not factoring here. I am using odd even principles. Okay, so out comes, because cotangent is odd, it becomes the opposite of cotangent of 1/6 x plus 6 pi. And just again to emphasize, I'm not factoring, I'm using my odd even principle. Okay, so that's where this came from right here, was from that odd even principle. All right, you with me? You still with me? Okay, so we're simplifying. Now, what we've done by doing all that work to simplify it, now I can just look at this equation and tell all the transformations that have happened. Okay, let's look at them. I have a phase shift. From right here. So I know my phase shift is negative 6 pi. What else is going on? Ooh, I have this 1/6. Okay, so that affects my period. We take the period of cotangent, that's usually pi, and we divide by that number, which is the same thing as multiplying by 6 over 1. So the period is 6 pi. All right, now we have our, our negative 3 here, and that tells me two different things. That tells me the amplitude is 3, the absolute value of negative 3. Okay, and then also because it's negative, that tells me that it was reflected across the x-axis. Great. So I have now just one other little piece of information. This 4 right here tells me that it's been shifted up. All right, so there's all of the information, and then we could go ahead and graph that if we were being asked to do that. All right, next I'm going to have you go ahead and try some of these. Pi over 4. All right, you ready to try this yourself? Okay, I'm going to give you a little bit of time. You can pause the video and try on these ones. Okay, so go ahead and pause the video and see if you can create a graph for number 1 and then the key information on of the transformations for number 2. Okay, if you need a little hint, it would be to simplify your input. Okay, you can pause. Okay, so hopefully you got an input now of negative 2 times x minus pi over 4. And now the next step is to think about odd or even. Okay, so it'll give you a little minute to think about that. Okay, so tangent is an odd function, just like cotangent, because we have sine over cosine, and that'll end up just being an odd function. So we would have the opposite of the negative there, the opposite of negative tangent of, okay, change the input to opposite of that original input. Because it's odd, we change, and that would be, give us a positive tangent there. Good. Okay, now you're ready to think about where your tangent would start and stop based on your phase shift and your period. So I'm going to give you a second to think about what you think the phase shift is and what you think the period might be. Okay, so phase shift is pi over 4. There's our pi over 4 for phase shift. Now, just be careful with when you're trying to figure out your period. That 2 is where we're going to divide the original period by 2, by that number. But just be careful because since we are in tangent, the regular period of tangent is pi. Okay, so our period should be pi over 2. Okay, now we're ready to start drawing our graph. Now, most people that I know don't just in their head have this memorized, that tangent pi over 2. And you'd actually maybe be surprised that I have to think about this, even math teachers. Okay, so, and then shifting that, that's just a lot of mental math to do. So in terms of kind of like this, the start and the stop, with tangent and cotangent, that can be a little bit hard to think about. What I like to do is I just like to go for asymptotes. Okay, where's my original asymptote for tangent? Negative pi over 2. Where's my other one? Pi over 2. So I'm just going to figure out what those asymptotes are. So I take whatever my original input was, and we'll just solve for x, and that'll just tell us what those asymptotes are. Okay, solving for x. For the first one, we would get, subtracting pi over 2 from both sides, we end up getting x is equal to pi over 2, and then for the second one, we get that x is 0. So now we'll go ahead and get our tangent graph drawn in. Okay, so I'm going to give you a little bit of time to think about that, kind of go through, analyze it, see if you can figure out how I came up with all of that. And now when you're ready, you can move on to the second one. And just pause, and then when you start it up again, I'll just show you the answer. Okay, so there we have all of our transformations.